Today we will begin Module 5 by looking at ratios, proportions, and geometric mean. So a ratio is just a way to compare two integers typically seen as a fraction or as two numbers with a colon in between. So we're just going to start today by simplifying the ratio, just like you would simplify a fraction. So the first one is 64 meters to 6 meters. So what we want to think about is what number goes into both 64 and 6. So immediately, because they're even, I know that they're going to be divisible by 2. So I might start by saying 32 meters compared to 3 meters. And then I would want to test, is there any further way to simplify that? And at this point, that's as low as I can go. But you may notice the one on the right, we're in two different units. So typically for the purposes of this class, we're going to try to maintain that these ratios are in the same units. So we either want to convert feet to inches or inches to feet. And the easiest way to do that is to go ahead and multiply that numerator by 12 so that we get 60 inches over 20 inches. And since this is a ratio, we're going to keep it as a fraction, because even though 60 divided by 20 is going to give us 3, that doesn't represent the ratio. So we're going to say 3 inches to 1 inch. 24 to 3, now we've written that ratio out in words. Again, both of these could be simplified to say 8 yards to 1 yard, because they're both divisible by 3. The last one here, we've got centimeters and meters. Now, a lot of us may not be comfortable with the metric system, so here's a little reminder. The saying we use is King Henry died while drinking chocolate milk, to remind us of what the metric system looks like. So currently we have meters, which would be considered our whole unit. And then on the left we have kilo, hecto, deca, the whole meter, deci, centa, and milli. Pardon that interruption, guys. So we're going to try to get from either centimeters to meters or vice versa. So at this point, I've got 150 centimeters and 60 meters. It might be easier to exchange this guy. So if I look at the meter that's here, I'm going to go right twice, which means I need to move my decimal to the right 2 times to get to centimeters. So I've got 150 to 600 centimeters. And that's kind of the nice thing about the metric system, is you're simply moving that decimal left or right. So at this point, both of these are divisible by 150. So 1 centimeter to 4 centimeters. So again, for the purposes of what we're going to do here, we're going to try to make sure our ratios are as simplified as possible in either fraction form with a colon in between or written out in words. And we want to make sure that they are in the same units. So now let's try a word problem. So we're going to use the ratio to find a dimension given the information here. So it says you're planning to paint a mural on a rectangular wall. You know that the perimeter of the wall is 484. So 2 key things already. We know the perimeter of a rectangular wall, and that the ratio of length to width. So I'm going to make a note here that this is length to width is 9 to 2. Find the area of the wall. So my end goal is to say the area is blank. So then, circling back to what I know, it's always a good idea to give yourself a picture if you can. So we've got a rectangle where we've got 9 times some number and 2 times the same number, because remember that a ratio has been simplified. So this used to be 9 times some number and 2 times some number. But to represent that number, we just placed a variable, and in this case we chose x. So for perimeter of a rectangle, we know that we're supposed to have twice the length plus twice the width. So looking at what we have, I know the perimeter is 484. I know the length was first, so that's 9x's, and the width was 2x's. And so what I'm going to do is I'm going to solve for x. And what that's going to tell me is by how much those ratios were simplified. So I've got 2 times 9x plus 2 times 2x. In total, that gives me 22x's. And then if I divide by that 22 on both sides, I end up finding out that x is 22. Which means if I go back to the original ratio, this used to be 9 times 22 and 2 times 22, which means my length was 198 and my width was 44. So if I know that information now, I know that I can multiply length times width to get area. So 198 times 44 gives me an area of 8,712. Since this is area, I'm going to make sure I say feet squared. And I've now provided them with what information they need. So here are a couple of other problems that are going to have ratios involved. So I'm going to do one, and then I would recommend that you try the next two on your own, and then unpause the video to check your answer. So the first one says the measures of the angles in a triangle are in the extended ratio, which we're going to talk about a little bit today and tomorrow. And that just means you've got multiple pieces. There are more than two numbers being compared. But anyways, we've got the ratio of 1 to 2 to 3 for the angles. So again, anytime you can, give yourself a picture. We've got 1 times some number, 2 times some number, and 3 times some number. And since these represent the angles of a triangle, we should know at this point that by adding all of those angles together, they should add up to 180. So 1x plus 2x plus 3x should equal 180. That's really 6x should equal 180. So 180 divided by 6 tells me that x is 30. Now notice here, we're looking for the measures of the angles. So now I need to go back. 1x would be 30 degrees, 2x would be 60 degrees, and 3x would be 90 degrees. Again, I would recommend that you try the next two on your own and then come back and check. Since we're talking about complementary this time, we have 2x plus 3x should equal 90. 90 divided by 5 tells us that this ratio has been simplified by a factor of 18. So I used to have 2 times 18 compared to 3 times 18. So if I double 18, I find that one angle is 36 degrees, and if I triple 18, I find that the other is 54 degrees. So those are the two angles within my complementary angle pair. The next one says the perimeter of a room is 48 feet, and the ratio of length to width is 7 to 5. So again, we're looking at a rectangle here because we've got length and width. So perimeter says add all of your pieces together. So we've got 7x, 7x, 5x, and 5x. So if we add all of those up, that is 24 x's. That should equal 48, which means my x value is 2. So it does say here that we need to find the length and width. So the length was listed first. So length is 7 times 2, so that would be 14 feet for the length. And 5 times 2 is 10 feet for the width. So now we're going to take a look at proportions. So proportions compare two ratios using an equal sign. So to verify that a proportion is true, you can cross multiply and see if you get truly something that is equal to each other. So 2 times 15 is 30, and so is 3 times 10, so I know that this is a true proportion. Proportions are when two ratios are equal to each other, like I said before. However, we're going to refer to the four pieces as A, B, C, and D in this next example here. and we're going to refer to them in that order. So we've got the first, second, third, and fourth. So the numbers in the middle are what we call the means of a proportion. So they're the numbers in the middle. And the first and the fourth are what we refer to as the extremes of the proportion. And that's going to come into play a little bit later in this unit, but I just wanted you to be aware of those terminologies for now. So if they were to ask you for the fourth proportional, what they're really asking you for is the fourth term. And I just realized I have a typo here. That should be spelled F-O-U-R-T-H, so forgive me for that. But if they are looking for the fourth proportional, they really want you to set up that 3 over 4 equals 5 over what? So we're going to set it up in that order where we have the first, second, and third term, but we're looking for the fourth. Then we can cross multiply. 3x equals 20, and we are going to end up with a fractional answer here, and that is totally okay. So if we divide 20 by 3, we end up with 6 2/3. So the fourth proportional would be 6 2/3. So there are several properties of proportions that we're going to talk about, so you may want to pause the video throughout this and jot down some information. But the cross product property is something that you already knew. So the product of the extremes will always equal the product of the means. Again, product means to multiply. The reciprocal property says the reciprocals of any proportion that is equal will still be equal. So we can flip those fractions upside down and still have a true proportion. If you interchange the means of a proportion, so if we switch the two middle terms, you still have a true proportion. And if you add the value of each ratio's denominator to the numerator, then you form another true proportion. And basically what you're doing there is you're adding 1, because if you think about that, if you're adding that denominator, you're taking that fraction to 1 and that number instead of just that number or just that fraction. So we're going to do a couple of these together, and I'm going to have you do a couple on your own. So with solving a proportion, we're going to cross multiply. So starting with the first example, we have 1 times 3y, that's 3y, and 2 times y plus 1. Notice there I did protect that binomial or that two-term denominator with parentheses. So I have 3y equals 2y plus 2. Once I distribute that, which means y is 2. Then I'm going to move down the line here. We're going to cross multiply 14 times y minus 3 equals 7 times y. So 14y, 3 times 14 is going to be 42, so minus 42 equals 7y. Negative 42 equals negative 7y, so y is 6, and so on. Now, these next few, the one below here and the one on the bottom on the right, they're going to come out to be quadratics. So remember, when we have quadratics, we either need to factor if we can't get that x squared and the x term to go away, or we may occasionally get lucky and that quadratic term or the squared term may cancel out on both sides. So looking at the last one here, I've got x plus 7 times x plus 2 equals x minus 5 times x minus 2. So be careful here how you distribute. So I've got x squared plus 2x plus 7x plus 14 should equal x squared minus 2x minus 5x plus 10. And you are going to be extremely lucky here. If you try to collect your x squareds together, they are going to cancel out. So on the left-hand side, I have 9x plus 14, and on the right, I have negative 7x plus 10. So adding my 7x to the other side gets me 16x, and subtracting that 14 from both sides gets me to negative 4. So x is negative 1/4 once we divide. Guys, I would recommend that you go ahead and try these two on your own for practice. and then unpause the video to check your final answer. Alright, and there they are. We end up with x is 9 and x is negative 2. So for these, we're going to find the ratio of x to y. So the ratio of x to y means that we need to come up with a fractional representation of x over y. So what this means is we need to get on one side of the equal sign, x over y equals something. So looking at this first example, what I want to do is I want to get rid of that 3 because I know I need x over y on one side of the equal sign, and I already have 3x there. So I'm going to divide by 3 first, and that's going to give me x equals 5y over 3. Now at this point, I need to move that y to the denominator of the left side. So I'm going to divide by y so that that cancels out, and divide by y here so that I have x over y equals 5 over 3. So my ratio of x to y is 5 to 3. Looking at the next one, I'm going to do the same process. I'm going to divide by 4 so that I have x equals 6y over 4. Then I'm going to divide by y to get that to the denominator, which is going to give me x over y equals 6 over 4. And at this point, 6 over 4 can be simplified, so x over y equals 3 over 2. So the ratio of x to y would be 3 to 2. For questions like the following, we just want to set them up where we distribute or cross multiply and get it in that x over y format at the end. So this would be 3x plus 6 equals 2y plus 6. My 6's are going to cancel out, which they should, right? If we're going to create a ratio of x to y, we can't have those extra numbers. So those are going to go away. And then I've got 3x equals 2y. My process is going to look very similar to before. We're going to divide by that 3 so that we have x equals 2y over 3. We're going to divide by that y so that it cancels out here, and we have x over y. So my final answer is x over y equals 2/3. So the ratio of x to y is 2 to 3. Last but not least here, we're going to cross multiply. 3 times 4x plus 2y should equal 4 times 2x minus 5y, and we're going to distribute. 12x plus 6y equals 8x minus 20y. We're going to clean up where we can. 4x equals negative 26y. If I divide both sides by 4, and I'm going to bring this up here, we end up with x equals negative 26 over 4. The y is still in that numerator. So dividing by y, x over y would equal negative 26 over 4. We're going to simplify that here. Both of those are divisible by 3. So divisible by 2. So we've got negative 13 over 2 as our ratio of x to y. Guys, there will be a question like this. on an upcoming quiz and on your test, so make sure that this is not something you forget how to do between now and test day. So a couple of you along the way this semester have noticed that some of your answers for your previous homeworks have been in what we call simplest radical form. And that's not something we talked about yet, so that's going to be something that's new to us here. But what that means is we want to take whatever information we're given, and I'm going to try to space this out a little bit better here. We want to take whatever information we're given and rewrite it in terms of a square root. So we're not going to approximate, we're not going to have any decimals, we're going to try to just rewrite this a little bit nicer. In order to do that, what we need to talk about first is what are our perfect squares. So perfect squares are whatever you get when you take any number times itself. So 1 squared, 2 squared, 3 squared, and so on. So what you may want to do is pause for a moment here and generate the list of perfect squares from 1 through 12, meaning 1 squared, 2 squared, 3 squared, all the way through 12. Now the reason we stop at 12 is that typically encompasses all that we need. Now obviously you could keep going, but for the purposes of the numbers we're going to look at, that's probably the highest that we would need. And to leave something in simplest radical form, what we're going to do is we're going to look for a perfect square that divides into the number that we're given. So if I have the square root of 75, the largest perfect square that divides into 75 is 25. So I'm going to rewrite this as 25 times 3, because that's the same thing as 75. And then using the property of square roots, I can break that up then into the square root of 25 times the square root of 3. And the square root of 25 is 5, and my square root of 3 remains. So the square root of 75 in simplest radical form is 5 square roots of 3. Now a good way to check yourself is to type into your calculator the square root of 75 and see what you get. And then to type in 5 square roots of 3 and make sure you get the same thing. So in both cases you should end up with approximately 8.7 if you round. And if you come up with different answers, you know you've done something wrong along the way. So looking at 90, I want to look for the largest perfect square that divides into 90. I know 9 goes into 90 10 times. So then I'm going to break that up into the square root of 9 times the square root of 10. The square root of 10 is an ugly decimal, so I'm going to leave that alone. But the square root of 9 is 3, so I can rewrite that as 3 square roots of 10. I would recommend that you try the next few examples on your own. Pause the video and then come back and check. And you're going to notice that I'm going to start skipping some steps here. You're welcome to do all of the steps, but I do want you to get a little quicker at them eventually. So let's see, 60 is divisible by 4. Is that the biggest one? I think so. So we've got 4 and 15, so that becomes 2 square roots of 15. Now you'll notice I paused there, right? Because 60 is a large number, so I tried everything that's lower than 60. I made sure that none of these numbers here could divide into 60 before I got to 4. And then once you get to 4, we've got 2 square roots of 15. And a good way to check your work here is to make sure that that 15 is not divisible by any of those perfect squares that are less than 15. With the exception of 1, right? We could rewrite anything with a 1, so we typically don't use that one too much when we're rewriting for perfect squares. Last but not least, for 30, 30 is going to be divisible by, let's see, it's not divisible by 25, it's not divisible by 16, it's not divisible by 9, it's not divisible by 4. So in this case, square root of 30 is the most simplified version of that I could have. So that would be my final answer. The reason we're going to talk about that is in this unit and bleeding into the next unit, Module 6, we are going to start to talk about this concept of a geometric mean. So a geometric mean wants you to find what two numbers would represent the means in a proportion using the two original numbers. So whatever two numbers they give you, in this case 3 and 27, are going to represent the extremes within that proportion. And we want the means, the geometric means, to be the same number. So if you notice, what happens is when we cross multiply, excuse me, we end up with x squared equals 3 times 27, which is 81. And then when we take a square root, remember that we want to make sure that we include the positive and the negative answer. So once I do that, once I take that square root, that's positive or negative 9. So notice up here, though, that it says the geometric mean of two positive numbers is the positive number, right? So really the only one that's going to count here is 9. But the reason we did that here is just as a quick reminder that when you do take a square root, there are two answers. In geometry, we're primarily going to take a look at the positives. So let's do one more together, and then I'll have you do the last two on your own. So we've got 4 over x equals x over 7. So that's going to give us 28 equals x squared. So I've got the square root of 28. And then from here, I want to see, do any perfect squares divide into 28? Yes, that's 4 and 7. So the square root of 4 is 2. So 2 square roots of 7 is the geometric mean of 4 and 7. Again, I would recommend that you pause the video here and try the next two questions on your own. Then unpause to check your answer. And your final two answers are here for you. For the third one, x equals 5 square roots of 2, and for the last one, 4 square roots of 3. Guys, if you have any questions about any of this, feel free to email me. Have a wonderful rest of your day.